Okay, so today we're going to look at integrating sine to the power of n kx and cos to the power of n kx. Two most common values of n happen to be 2 and 3. In order to do anything to the power of 2, we first need to remember the double angle formulas. So we had cos 2x is equal to 2 cos squared x minus 1, and it also equals 1 minus 2 sine squared x. So, if we have a look at transposing, to get cos by itself, cos squared by itself, take the 1 over, divide by 2. So cos squared x is actually equal to a half cos 2x plus 1. And if we do a similar thing for sine, we get sine squared x is equal to a half 1 minus 2. 1 minus cos 2x, sorry. So, if we are faced with integrating or anti-differentiating sine squared of 3x, for example, what we need to do is replace sine squared with another form of the double angle formula. So we get half 1 minus cos. Now, 2x actually stands for 2 times the angle. In our case here, the angle is 3x, so therefore it's 2 times 3x, which means we're actually anti-differentiating half 1 minus cos of 6x. Right. We can take the half out, and we're left with 1 minus cos 6x dx. So we're going to integrate that. Half square bracket, because you've done the antiderivative, or you're doing the antiderivative. The antiderivative of 1 in terms of x is x. The antiderivative of cos 6x is 1/6 sine 6x plus a constant. And antiderivative of cos is just sine, so therefore there's the answer. In terms of sine, multiply back in, you get x on 2 minus 1/12 of sine 6x plus a constant. No? Notice you'll get this pattern every time. So every time we're anti-differentiating sine squared, we expect to get something in the shape of x on 2 and then sine 6x. Okay. Now we're going to look at integrating something like cos squared. Let's say it's x on 4. All right. Once again, sine squared, cos squared. Just get it into your heads. You cannot anti-differentiate them straight the way they are. So we need to replace it with the double angle formula. Now, it's saying that cos squared x is equal to a half, bracket, cos 2 times the angle. This time, my angle is x on 4. So it's actually a quarter of x. If I double a quarter, I get a half. So it's cos x on 2 plus 1 dx. Okay, so it's cos 2x plus 1, half of that. Now we anti-differentiate, half, bracket, the antiderivative of cos of x on 2. Well, first of all, the antiderivative of cos is sine angles, x on 2. My value of k here is a half, so what I'm doing is I divide by a half, so this turns into 2 plus x plus a constant, c1, multiply through, you'll get sine x on 2 plus x on 2 plus a constant.